Although I am mainly an engineer, the modern world still requires even engineers to understand marketing and how products are developed. Overall, this gives you the opportunity to start a business or manage a business. The foundation is still engineering knowledge, but you also need to have pretty good knowledge in marketing and even in sales. That's why I often listen to different channels in different languages to see how people sell, how they present, how they do reviews and so on, including channels in Russian as well. In different countries, there are good bloggers, truly top-class specialists who present and sell different things. And I came across a very interesting conversation. There was a big discussion, good equipment. They were talking about how things are bought, which foreign brands, local brands, and so on. And in the middle of this discussion, suddenly I hear a statement that there is a very good brand, a Japanese one, Audiophile, which really makes exceptionally good equipment. It's expensive, but there are no shortcomings. Every button, everything will work well, last a long time, everything is high quality. And suddenly they say that the power cable that comes with this expensive amplifier is just for testing. It's not for actual use. And that's when I woke up. Something about that statement was wrong, I thought. In the audiophile industry, in marketing, there is a unique power cable, an expensive one. And then my engineering knowledge really woke up, and I listened very carefully to how they were explaining all this. It turns out it's not just the power cable, there's also a fuse. I listened to the whole discussion and the arguments and so on. But from an engineering point of view, a power amplifier just doesn't work like that. All these arguments made for this exclusive cable, it does all kinds of things. If you don't use this cable, nothing will work at all. And how you're supposed to clean the mains power, which is dirty and affects the sound. But the thing is, a power amplifier doesn't work like that. So let's take a look. Let's see how a power amplifier actually works and why I don't agree with that argument. And of course, just out of curiosity, I did a little review to see how much these audiophile connecting cables cost, what they look like, how many are being sold, and what people write about them. This is a new area for me, so I found this kind of audiophile power cable. Well, if a standard cable costs about €1.50, this one costs 32, that's 20 times more. As I understand, that's not the price limit. Some are even more expensive. But if you take a careful look at this cable, well, it's just a cable with a pretty large cross-section. But if you take this mass of cable and all these connections, it's kind of bulky. From my point of view, from an engineering point of view, this is not a very good cable, clearly. It's too big. Also the question here, is the plastic right? Is it heat resistant and so on? In general, it breaks your socket, in my opinion. Well, okay, that's my subjective opinion, but this one is even worse. Look, the fuse is more expensive than the cable. And in that conversation where marketing approached this with a certain enthusiasm, like people bought such expensive equipment, but they don't invest in things that improve the sound, for example, the power cable and this fuse. Well, so these marketing guys want about 100 extra for this sale, which isn't really that expensive. Well, considering that every morning I drink coffee with a cookie, which costs €5 in my country, that's €25 a week. So, basically, that's a power cable. I could skip coffee for a week and buy such a power cable. But there's something wrong with this marketing, because the amplifier works differently. Let's look at the amplifier's architecture and see why all these things don't actually affect how it sounds, and why Audiophile supplies their very expensive amplifiers with a simple power cord. These Japanese engineers, they're not fools, believe me. If it was necessary, they would have put in the best possible cable to make sure their equipment sounds exclusive. It's not that expensive compared to the cost of this amplifier. Actually, I got really interested in the fuse, and as an engineer I didn't know what these audiophile fuses were, or how they promote this product. Well, basically, Here's a standard fuse, and this is a standard fuse is made of zinc, or tin-plated solder, nickel-plated brass, glass or ceramic, air or sand. Well, if there are high voltages, that's not our case, so that there's no fire or sparks. Audiophile? Well, a special one, not for professionals, I'd say. Silver gold or copper with a rhodium coating? My God, silver gold exactly. This is a piece of jewelry, dense ceramic, quartz and carbon fiber. Silicone anti-resonance gel, or beeswax. Well, that's from the realm of fantasy. There's nothing rational here, believe me. So, what are the key words used to justify the price of this expensive fuse? Cryogenic treatment, so we cool it and heat it there. But in principle, that's not bad, because if there's some real defect when we cool and heat it, it definitely shows up. Actually, this is also used for very reliable designs that operate in different temperature conditions in the automotive industry. When we made this board, it really does get cooled and heated. All these temperature deformations, thermal expansions and contractions reveal any soldering defects. This is basically normal. Well, there's no cryogenic treatment here, just thermal processing, thermal testing. The directionality here, I don't understand. I need to study more. Generally, there shouldn't be any directionality. Maybe there's something I don't know. Choosing damping. Well, that's also a bit of a mystery to me. I won't argue. Maybe there's something I don't know. But the first one, yes, the first one is the right approach. I think everything is fine here, to be honest. Well, in general, there's a big debate between engineers and audiophiles, and basically everyone can stick to their own opinion. I agree here. Everyone has the right to their own opinion. I'm not going to argue about that. And there's one theoretical thing we need to understand. So, a large inductor and a large capacitor. And in this case, the large inductor is important to us. So, an inductor is also an energy storage device, and the inductor has resistance that depends on frequency, and here is the formula for calculating it. Where L is the inductance of the coil, measured in henries, but mostly we use millihenries or microhenries. A millihenry is already a lot. A henry is a very large value. Frequency. And 2p is a constant. So, in this formula, if we have, for example, a power transformer, that's a large inductance, we only have a changing frequency, and the higher the frequency, the higher this resistance. A classic power transformer is a large inductance on a steel core, and basically it filters by two parameters. It filters by inductance, and this steel core doesn't let high frequencies through at all. That's why you can't make a better filter than a power transformer. The filters we see with capacitors and various other things on specialized filter boards can't compete with the filtering qualities that a large power transformer has. And all classic class AB amplifiers have such a power transformer. So, you don't have any problems with interference at all with the amplifier's transformer in high-end, good, powerful amplifiers. There's a huge transformer there. I don't know, it weighs about 5 to 7 kilos like a dumbbell. Basically, there's a lot of inductance there, and everything gets filtered. Everything gets filtered. So the argument that you need the wire to filter the mains voltage just doesn't hold up according to physics. The mains transformer filters much better than your expensive wire. The second argument is that the wire should have a huge cross-section. I don't know, like 4 millimeters. The key parameter of a good power amplifier is peak power. For example, when a drummer hits, it immediately delivers a lot of energy, and for that we need a very thick power cord. But the thing is, it doesn't work like that. The principle of how a power amplifier gets this peak power is completely different. And let's look at an example of a good engineer and his flagship design, how the peak power is achieved there, and why this cable doesn't affect this parameter at all. Here we have a modern power amplifier. It's Class D. It's flagship from a good manufacturer. Ice Power. I made special kit for this one. Basically, I sell this box worldwide, and people can buy it themselves. This unit is available at retail. So it comes with a local warranty and my own design. It's selling well. I've sold it in 42 countries basically. It's doing well. And you can get very good amplifier for a reasonable price. And to position myself in the market, I have a relatively simple box, but it's made specifically for this particular unit, so everything is optimal. As you can see, there are short wires, outputs. Here's a fan that pulls the air out, and at low speeds you can't hear it at all, but it cools it very, very well and efficiently. And basically, this is a system that can work for a long time and reliably in different countries. And when someone buys and assembles this amplifier, they write a lot of thank you letters about how good that sounds. Yes, because it has a classic good amplifier here that meets all modern requirements. And its peak power is 600 watts per channel at 8 ohms and at 4 ohms. That means at 4 ohms it is current limited, while at 8 ohms it is limited by the power supply of the amplifier. Let's see how it's made, because this is a flagship, a specific company, a good Danish developer. And how did they achieve this exclusive high peak power? Why does everyone write thank you letters? Because as a power amplifier it works very well. It can drive any speaker, both large and small, and it has low noise. But that's another story. Let's take a closer look just at the unit itself, so everything is visible. So how is it built? Yes, well, of course there's the power connection, then a simple ceramic fuse. And believe me, the guys who worked on this unit, they're not stupid at all. If it needed an audiophile grade component here, they would have installed one. Trust me, this is a flagship model. It has to sound better than anything else and be both excellent and stable. That means the original power supply goes through an additional filter, a mains filter, and it's more so that the unit doesn't send anything back. But it also filters everything that comes through the line, though very little actually comes through the line. There's a good mains filter here, it already filters, then there's a rectifier, and then we have it here under this construction. There's a large inductor here for the power factor corrector, and then an even larger inductor. Again, the filter is huge, a huge filter, but it has a different purpose. This large inductor stores energy. This is the first storage unit, because for such an amplifier, we can't just suddenly draw the required current from the mains in any way. It will sag there, so we've made a whole series of storage devices where we accumulate energy for that surge for the drum. It's a short pulse, so once a second there's a big hit, a sharp edge. This sharp edge is a high frequency signal, almost 4 kilohertz, and we have to deliver that sharp edge instantly. So how is it done here? So here we have the first energy storage, and first we accumulate this energy, and then we boost it up to 400 volts, where the second converter operates at high frequency. And at high frequency, this transformer can handle about 5 kilowatts. Based on its size, at high frequency, you can run 5 kilowatts through it. It receives 400 volts at the input, which is converted into pulses, and it operates here. This is the primary side, this is the secondary side. Here it steps down and charges this capacitor bank, accumulating energy, secondary energy storage. The first one is here, energy is stored here, then we make 400 volts, and then more energy is accumulated here. And if you look more closely, see these large storage capacitors here, which are 10,000 microfarads. They also have these small storage capacitors connected in parallel for the first volt, for the initial biggest current output for that initial surge. and they're connected in parallel. 1, 2, 3, 4 also in parallel, and they have very low output resistance. If a current is needed, they deliver it instantly, and when they drop, then the Big Bang takes over. And when this Big Bang starts to deplete, the transformer has time to recharge it again. Why is this architecture used? Because any inductive element responds with a delay. If you request a large current from a big transformer right away, it can't do it. By its nature, it's slow. It accumulates energy, but it can't release it instantly. It can only release it after a short period. And capacitor, on the other hand, can release energy immediately if you ask for it, almost instantly. That's why these inductive elements store energy and then release it after a delay. The initial demand is met here, and then our whole converter, the entire power supply, wakes up and we recharge these capacitors again. And what kind of music pattern do we have there? It's like thump, 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 thump. Those are the biggest bass hits. When it comes to the mids, like the snare that goes at a high frequency, the power consumption is small. But with those first thump, thump, thump hits, we have to deliver a big woofer. And the whole architecture here is extremely precise. It's the same with classic amplifiers AB, where they have a big transformer. It has the same problem. It's big, it can constantly pass a lot of energy, but if you ask for sharp changes, it can't do it. It's always lagging. That's why at the output they have filters. The storage filter capacitors are also big. They're bigger for higher power. Sometimes it's 20,000, sometimes up to 60,000. The more you store, the more you can instantly deliver for that hit. Yes, that's the immediate response to the impact, which is very important. Otherwise the bass sounds smeared, but this way it's sharp and precise. And that's why the power chord doesn't solve these problems in any way. It doesn't affect it at all. If you measure it on the power chord, the total power of this amplifier, yes, 2 channels at 600 each, that's 1,200 watts, 1.2 kilowatts. But the average power consumption doesn't exceed 180. Because a music signal is like that. It has a crest factor of about 8 compared to a sine wave. Yes, it has a lot of peaks. And then there's a little la 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 la, then a big hit, and it will hit you in the stomach if there's a big speaker. Yes, you'll feel it with your whole body. So the power cable doesn't solve this problem. It's solved at the architecture level. If the architecture is too simplified, then you can't get good bass. If the architecture is correct, then you'll have that kind of bass, and even a simple cable will handle everything. So the engineers at Audiophile and the engineers at Ice Power, they know how this works. People, salesmen generally speaking, they chose the wrong arguments. Neither filtration nor instantaneous current has any effect on these cables. They say, we connected this cable and the bass started sounding better. But from a physics standpoint, that's simply impossible. So they're a little susceptible to that. And those who didn't buy a very expensive cable but bought a good amplifier sleep well. The stock cord that comes from the manufacturer is good enough. And those who didn't install such a super cool fuse for 40 euros, well, come on, it doesn't matter either. It's just a different architecture. So I agree with the sellers that Audiophile is a wonderful amplifier, and it's a great manufacturer, both the old and the new, and everything there is top-notch. But as for the extra sales, like this cable and some other super filtering devices for the power amplifier, I don't know, it doesn't make sense because everything is filtered very well at the level of proper engineering architecture. If we're talking about preamplifiers, well, there are also different solutions there. If the electricity is really bad, then what? In the computer industry, there are uninterruptible power supplies with 100% regeneration and a sine wave signal. Well, buy one of those, put it on your preamplifiers, DACs, and so on and so on. Well, the power amplifier is connected to the main power supply, so in general, the fewer elements there are, if it's made correctly. Yes, any additional element you put in there, some kind of filter, will just reduce the performance quality of your amplifier. Putting different ones in there is harmful. So, if we're talking about modern marketing, well, there are things that I think shouldn't be done because they just ruin your reputation. Well, for example, if you have a good client who actually has a lot of money and no limitations, then we sell him a good amplifier and explain it. We sell him a good speaker. He'll save on those pseudo cables and maybe buy some more important things, like a next level speaker, for example. Or if he's planning, he might use that money to buy several services, try them out, choose the best ones, and so on and so on. In general, the money saved from pseudoscience should be invested either in a speaker or in various experiments, in things that make us happy. And for all those who think that their amplifier doesn't sound good because they don't have a good power cable or an exclusive power cable, rest easy, you have the right, good cable. So what conclusions can we draw from this? So what's important for you are high-quality reservoir capacitors with low internal resistance. We need a proper, good, correct architecture, and here it is proper and good. We need a sufficiently powerful power supply. If you look at this whole setup, we talk a lot about the amplifier. It's just this much, right? But the power supply is this much. It's everything. The power supply. And the quality of the power supply determines the quality of your modern audio system, because this part, with modern semiconductors, we can build very well, but here it's expensive. Yes, this part is more expensive than this part. There's a lot of know-how here, a lot of science, but once it's been refined, it's not expensive, while this part is always expensive. If you have a class AB amplifier, a big one, you need a transformer, and you need good storage capacitors, very good ones. Yes, that's important. You can save a lot on this. Yes, competition is tight, but here it's impossible to save. This part costs almost nothing, yes, but this one is expensive. So, when buying new modern power amplifiers, we pay attention to the power supply unit.